Well, hello everybody. Welcome back to the channel. Thank you all so much for tuning in. Happy Friday. It is now Friday night if you're watching this video. We're recording as of Friday night. I usually don't do nighttime videos, but we're making an exception. I had a pretty busy day today. I'm relatively tired. You probably can't tell, or maybe you can. We're going to find out during the video. I am definitely at the point of the day where I'm just incredibly exhausted, like I hit a brick wall. But I did want to get this video out because there is quite a bit to talk about going into next week. We have severe weather that could potentially be ensuing for the Gulf Coast states. And then we also have winter weather that could be a concern for the Northeast New England by the time we get to our Thanksgiving travel, right around that Wednesday, Thursday time frame. So we're going to get into all that during tonight's discussion. We're going to really give you kind of an info dump here, but not a dump to where it's too much info. It overwhelms any of you. I'm going to try to make it so that way we all sort of are on the same page. We understand sort of what's going on and what still needs to be resolved in some of these models. Because I think what you're going to see as we go through this discussion tonight is that there is a crap ton of variability that exists still. It is 6 days out for the winter threat. It's 4 days out for the severe threat. So a lot of model inconsistencies that exist, but we're going to navigate through all that during tonight's video. So if you do enjoy the video this evening, be sure to like and subscribe. Share it with family and friends who will likely be impacted by those weather hazards. And with that being said, let's get into today's video. Before we do talk about the two concepts I mentioned, which is the winter weather threat, severe weather threat, today marks the 10-year anniversary of the November 17th, 2013 tornado outbreak that encompassed much of Illinois all the way through even Indiana. So Illinois, Indiana, and even some parts of Michigan, I believe. There was over 150 some tornado reports, and I might be even underdoing that. I'm just speaking off the top of my head, but it was a major outbreak for the lower Great Lakes. The Washington, Illinois tornado was rated an EF4. The National Weather Service in Lincoln put together a really good sort of summary. And it's really, this isn't even a summary, guys. I mean, well, this is a summary. But, I mean, they go, like, with the tornado ratings, they show you the different paths here, environmental data. They pull a couple SKUTs from that event. There is so much really just fascinating information here from that outbreak, from pictures to soundings to radar loops. So I just want to start off the video by giving a huge shout out to the NWS office in Lincoln. That's down in central Illinois. This is such, I strongly recommend that you guys really read through this. Whether or not you remember this event or were directly or indirectly impacted by this event, it was such a infamous tornado outbreak because of how late in the season this happened. And it really goes to show that tornado outbreaks still exist in the months that you don't expect it. November, December, January, February. Tornado season really truly is 365. It can happen at any time. Yes, tornadoes typically happen in August and September and June, July, in the summer months for places like Illinois. But as we saw with the November 17th outbreak, happens even in November around this time. So, of course, 10 years later, we definitely, our thoughts and our sincere prayers go out to those that were impacted by this. I actually know somebody who I went to school with who was strongly impacted by this event, actually grew up in Washington, Illinois, and certainly has a lot of stories to tell from his experience and being a young person too, seeing the damage that he saw is truly just heartbreaking. And so we had quite a few injuries during this event. We had hundreds of injuries, even several deaths due to this. Many people have perished. So even 10 years later, we still remember those that were deeply impacted, especially for those in Washington, Illinois. Our thoughts are with you even still. I know this event definitely affected me. I'll never forget, even up here in Northern Illinois, getting some pretty significant storms up our way. So hats off again. Lincoln, Illinois put this together so beautifully. And there's really a lot of information. Guys, even if you're not, an expert in meteorology, it doesn't matter, right? This is still a really good read, and I welcome you guys to read through it. And the link will be in the description down below for you guys to take a look. But 10-year anniversary. Gosh, I can't even believe it's been 10 years. It's just, time really does fly. It goes by pretty quickly. So with that being said, the other thing I wanted to mention that we didn't really get a chance to talk about the other night is kind of transitioning to winter, right? We just kind of covered what can happen during the winter season. Here's what's likely to happen during the winter season, and that's snowfall, right? This year is going to be different. The National Weather Service and NOAA has actually changed the snowfall threshold for criterion issuing a winter storm warning. So for example, if you're in a place like Texas, you guys remember that you don't need a lot of snowfall to get a winter storm warning. Usually it's about a couple inches of snow. In a place like northern Illinois and portions of the upper Midwest, it's usually, somewhere around, say, 6 inches. The criteria really varies depending on where you're located, right? Because if you're in the Midwest and the Northeast, you're getting a lot of snow as is. So your threshold will obviously be higher criteria for a winter storm warning, whereas places in the South, like the Gulf, your threshold is lower. Now, there were changes to the threshold for a winter storm warning in some localities. What this really accomplishes, though, is you got to remember, throughout the entire country, we have a whole bunch of weather forecast offices. It's not just one per state. Many times it's multiple. I'll use my home state of Illinois for example. You have Chicago, you have Quad Cities, you have Lincoln, you have St. Louis, and then you have Paducah, right? So all those littered about. You're talking collectively about 6 forecast offices that cover some part of Illinois. So let me, oh, you know what? I was just getting a call here. I forgot to put my phone on deafen, but that's okay. Let me just do that real quick. And guys, we're going to go with this video today. Usually I would retake this video, but we're already so well into this that we'll just leave it in as a blooper. Okay, anyway, so the difference here that we're seeing with this new implementation from NOAA is that while the threshold really hasn't changed much for a lot of these areas, the difference is it's much more uniform. So as you can see, we have about 6 inches for our threshold here in say, northern Illinois and much like the lower Great Lakes. The reason why they're doing this is, number one, to update those thresholds, just to kind of stay current with the times. But also, it's to create a more uniform map. Rather than having, say, Weather Service Chicago make their threshold 6 and then Quad Cities 4, instead they're both 6. Does that make sense? So really, it's to make sure that there's not a whole bunch of contradiction from neighboring weather forecast offices for how they issue warnings. If you remember back in the past, I have seen this on even several occasions where you have the same winter storm, but you might have Quad Cities, issue an advisory for the same storm, but then Chicago issues a winter storm warning and vice versa. That's incredibly confusing, right? Because you're thinking, okay, well, is the storm worse in one part versus the other? Well, no, it's just one office has a different sort of ideology with issuing the warning and the threshold for it than a neighboring office to the east and west of it, north to south. So this creates more of a uniform forecast to where, rather than having a whole bunch of localized contradiction between different offices, everybody's sort of on the same page, right? So the thresholds themselves really haven't changed as much, although I got to be careful because there are some areas that have significantly. It's really just to create more of a consensus amongst neighboring weather offices about what the criteria is for winter storm warning. So that way you, the viewer, and me too, we sort of aren't left confused and in the dark. Because when we're confused, we tend to not make the best decisions. And that's not our fault. It's just because we're doing what we're communicated. What is being told to us, what's being relayed to us. So NOAA, really at the end of the day, through this initiative and others, is trying to fix the communication issues that still exist between us, the general public, and NOAA. And this is just sort of one of the several ways that they're trying to do that. So I love this system. I think you guys are going to like it too. You may not notice it, but it really is going to be tremendously helpful for communicating winter weather going forward into the future. and we will probably see continued improvements to the warning system as a whole, hopefully in the next several years as well. All right, we got all of the news out of the way, so let's get into what we really were here to discuss. And that is what is happening right now and what is expected to happen with some of our weather events over the next couple to several days going into next week. In order to do that, we have to set the scene here, right? We got to know what our jet pattern is at the moment, so that way we at least have an idea of sort of where we're going. I'm not somebody that likes to jump right into the models. You guys know that. You've watched me for a while now. I really like to set the foundation and show you what's going on, and then we look at some models and we show you some of the discrepancies there. So let's begin first with just the lower 48, and we'll get a broad paintbrush here and just look at everywhere within hopefully 60 seconds. So as you see, we have an area of high pressure out towards the west coast, this ridge, or high pressure, right? Height rises. And you have a trough that is continuing to dig across the east coast and the northeast of New England. That is bringing some stratiform precipitation right towards the higher elevations, especially towards Maine, Vermont, New Hampshire. Could see some snowfall on the back end of that, not expecting it to be rather significant. We are looking towards next week as more of the time of concern for that winter system. Again, more on that here in a little bit. But that is where we're at right now. This trough is bringing down some below average temperatures for the Midwest, the upper Midwest, even getting back towards the eastern half of the United States. Meanwhile, we are seeing precipitation even extending along this Pacific jet for our friends in Arizona and New Mexico, seeing some showers there as well. That also includes folks back towards San Francisco and the northern and central valley of California. And then we do also have this little stripe of precip up towards mainly our higher elevations of Washington and Idaho. So the general trend, where we're at right now, remember when we talked even just last week, we were looking more at this trough, ridge, trough pattern to where we had cold air on either side, right? So cold air here, cold air here. So cold air on the west side, the west coast, and cold air on the east coast. And then we had an area of high pressure, this ridge that sat here in the lower Great Lakes, which brought us some well above average temperatures for the central United States over the last few days up until now, because what we've seen over the last 24 hours is that cold air with this trough bring about a cold front, which is located right along this line, and usher in some of those below average temperatures to the exact same areas that we're seeing some warmer temperatures to start out the week. So we have seen a shift from a trough ridge trough to a ridge trough. More of that cold air in the central and eastern United States, more of the warm air back towards the west coast. This has implications for what happens going into next week on both fronts, whether you're talking about winter weather or you're talking about severe weather. For the severe weather, we're really looking towards the Pacific jet. This guy right down here. This is our Pacific jet providing southwesterly flow into the Four Corner states, and our trough of concern is still off the coast of California, just in the vicinity of the Bay Area. That is going to meet up with our Pacific jet and eventually begin to dig into the Gulf Coast states and potentially producing some severe thunderstorm activity. For our winter setup, that's when we need to focus in on not just this Pacific jet, but also the polar jet. So we really have two jet streams here. It's not just one. We have a Pacific jet in the southwestern United States, and then we have our northwesterly flow with our polar jet, and that's up towards the Canadian provinces of Manitoba and Saskatchewan. Now that we've sort of established the baseline, the foundation for kind of where we're at, as I mentioned, let's talk about where we're going. And so we're going to look here at the GFS. It is just one solution, but we're going to go through a few different solutions, all right? And then what we'll do is we're then going to kind of dive into the severe weather, and then we'll go into the winter weather. This video will not have timestamps, so it will just be kind of one clean sweep. Of course, if you guys do want me to revert back to timestamps, I can definitely do that. But for tonight's video, just for the sake of time, because I know it's getting late, I'm just going to do kind of one run through of this video and just kind of lay it all out there on a silver platter. So, the GFS solution as of tonight, sort of coinciding with what we see right now in Go 16. Ridge, trough, here's our Pacific jet, here's our polar jet, right? So our main concern is really going to be with this guy. I want to see what happens with that trough, because the fact that that has essentially displaced this far south, this troughing feature, that likely is going to have implications for severe weather. By the way, this is also high pressure, right? So we have high pressure down here towards Mexico, and then here's our polar jet towards the north. So we have two different air masses to talk about, and that should really help to amplify this shortwave trough by the time it moves on land here. This will take us into Sunday. By the time we get to Monday, this is when things are rather interesting, right? So it really is sort of the Monday, Tuesday time frame. The GFS has a different interpretation of this. So as you see, here's your shortwave trough. But notice that what happens, oh, I was about to do an eraser there. Beyond that point, what happens here? We get this system to actually form into a cutoff low. That dives south into northwestern Mexico. And much of your flow, you get a secondary trough to form just in the lower Great Lakes and then eventually move east. So winter weather, yeah, that's a concern, right? But when we talk about severe weather, it really is interesting because we have very strong winds. Remember, this is our 500 millibar height level. This is our jet stream level. Really strong winds aloft. We're talking about 68 to 76 knots. You have an area of high pressure out towards the Yucatan. That's advecting moist air, right? More on that here in a moment. So all the ingredients are here, especially for like Monday into Tuesday, from a synoptic point of view. Let's now take a look at the 850. All right, so 850 is going to show us any sort of low-level jet that we can find. It also will show us where that low pressure sets up. So our low pressure is going to be somewhere in this vicinity, right, near like Oklahoma and Arkansas, even getting back towards Louisiana. The 850, the low-level jet, is certainly present. If you follow these lines, this is actually showing us south and actually just southerly flow. So we do have moisture advection here. Remember, when I'm talking about severe weather, I look for four things. It's called SLIM. SLIM is the acronym. So I am looking for SLIM. I want shear. I need instability. Sorry for the handwriting. Actually, that's crap. That's supposed to be lift. My bad. Let's actually change that. So this is supposed to say lift, right? I need instability, unstable for short, and then I need moisture. All right, so we will keep this acronym on the side here, and we'll check off and see if we have it. All right, and it just deleted. So you know what? That's fine. We'll remember it. So here is our low-level jet. We have southerly flow. We have strong winds aloft. We have forcing aloft. And by the way, this is looking at our upper-level jet, which we didn't look at yet. This is talking about 120 to 130 knots of upper-level jet. That's really strong winds aloft. And that's all Pacific flow. So right away, I mean, let's put kind of a caveat here, disclaimer. I haven't looked at any other models yet. I'm just looking at the GFS. There is going to be variability here, right? Because we're still 4 days out. Our system is off land. You know, we don't get a lot of good in situ observational data off the coast. The only time we really get better data is when that system moves onto land and we can launch a weather balloon into that sucker, and then we can get better data that can be fed back in the model. So that's why there's inconsistencies. But just using the GFS, if we're trying to figure out severe weather, well, I mean, just from a synoptic point of view, we have a pretty strong forcing regime. We got low-level advection. We have upper-level shear. Okay, well, so far so good, right? Now, let's take a look here at moisture. So we'll look at dew point. Okay, well, if we go into, this would be late Monday night into Tuesday, we have moisture. We do. So if we look at our color table here, you're talking about 60 dew points. And actually, you know what? Let's get a little bit closer if you don't mind, guys. I think we can see this a little bit better if we zoom in. And here it is, right? This is taking us into what would be Monday morning into eventually Tuesday. We have dew points. Dew point spread is, in this case, around 60 to 65. That's great. That's more than enough, right? So we have moisture. That's good. We have shear. being the upper level winds and our winds with height? Yes, we do. Check. Do we have instability and do we have lift? Well, we have lift because even if I didn't see it on a map depicted for me, there is definitely a cold front here and there is definitely a warm front. How do I know that? Because these dew points crash off like a rock. So it could also be a dry line. We haven't determined that quite yet, right? We can look at the temperatures and find out as well. But more than likely, because of this sort of westerly orientation, there probably is some sort of dry air here, but we do know this is a cold front. This is not a convergent boundary. This is not a stationary boundary. We have a cold front, and we also have a warm front. All right? So we've established that. We have lift as our fronts. We have shear with the winds with height, low level, upper level, moisture. The question now becomes, do we have instability? That's the final question. So let's look at that. And we can actually find it here on severe weather. And in this case, we're just going to have access to the surface cape, which it should suffice. So here's what's interesting. Look at our cape profile. Okay, so general spread on surface cape, and keep in mind we aren't looking at mixed layer cape, and I'm not looking at most unstable. I'm kind of breaking the rules a bit. But if we're just analyzing surface cape, you're talking about, I don't know, 600 to about, we'll say 800 joules per kilogram. It's cape, right? I mean, there is some instability here to work with, but if history serves us well, it's kind of low. If we have cape with 600 to 800, the only time that would really be sufficient for us, for like a widespread severe weather event, would be if we had a cold core system. We don't have a cold core here. And I won't show the map. Actually, I will. I will show it quickly just to sort of verify that. So upper air temperature, we look at 500, right? We don't have a cold core closed low. So we can rule that out. Huge X, right? That is one of the only few scenarios where that type of cape profile would be sufficient. But in this kind of setup, if we go back here to the cape, that's really low. It's really low. Again, it's cape. It's just not. It's just not as sufficient for a widespread severe event. So cape we are lacking. Keep in mind, this is the GFS. This is just one solution. So if we were to even, I don't know, we could also look at even the NAM 12K. Let's look at more of a convective allowing model. Well, in this case, this convective allowing model has a little bit more cape. We're talking about 1200 now. About 1200 to 1400. That would be a big difference. So at least right now, the biggest question mark is what is the cape profile going to be? We're going to look at a couple of soundings here in a moment, and we'll see sort of what's going on even there. But, you got some of the cams, at least the NAM, the North American model, showing a heightened level of cape. That's critical, because if you get more of that instability, say greater than 1,000 joules per kilogram, now we're in business. Now we're talking about something that could be rather significant. 600 to 800 might limit the severe coverage on that, if we're going off the GFS solution. So as we've kind of established tonight, with the severe threat going into Monday and Tuesday, there is variability here still. And my argument is that we probably won't resolve that until maybe Sunday morning. Once that system of concern moves on land, we can get a better handle on some of those observations because we have weather balloons, feed it back into the models, and during that time, we also have more convective allowing models available to us. The HRRR would be available, even some of these 3 kilometers, more data regarding the FV3, the WRF. Some of these are technically available now, but you get more coverage as you get closer. So, point is, guys, if you're in Louisiana, Eastern Texas, Arkansas, Oklahoma, there is still plenty of question marks that I have. And it's not a lot. Actually, I shouldn't say there's a lot of question marks. Really, the biggest question for me is, what's the cape? how much instability are we getting out of this thing? If we get enough instability, yeah, we could have a decent severe shot on our hands with all hazards possible. Large hail, damaging winds, and tornadoes. In order to really establish that too, we have to look at a couple of soundings. So to conclude the conversation on the severe weather front, let's go ahead and do that. So we'll quickly hop over to our soundings. And I won't even pull a couple. I think I'm just going to pull one just for the sake of conversation. And so I'm thinking we could do one around Shreveport. I think Shreveport would be fine. That should be okay. So Shreveport Regional. And we will look at GFS deterministic, because I don't think the NAM's going to go out that far. Not really. So we'll look at the GFS here and see. Actually, you know what? All these, I beg to differ. They're all going to go out to about 12Z Tuesday. So we'll just look at this one for now. All right, so this is taking us all the way out to what would be Tuesday morning. So I want to look at Monday night, Tuesday morning. It looks like this model's having a tough time rendering it, though. It's kind of odd. I don't know why it's doing that. So, yeah, you know what? It is. All right, we're actually going to try Shreveport downtown and see if that loads. There we go, kind of. Okay, it's having a bit of trouble here, guys. Weatherbell's having some technical issues with outputting this. But at least on the GFS deterministic, as you can see, if we were talking about, say, like Monday morning and afternoon, you do have veering with height. So that's our low-level jet we're talking about. Your winds are turning with height, so you do have veering. And your lapse rates are actually somewhat decent, right? 5.6 Celsius per kilometer, 6.4 Celsius per kilometer from 850 to 700. There is instability. There is cooling with height. So we have that too. The Cape profile, I mean, at least from what we see later on in the day, it's kind of lacking. It's not great. And by the way, our LCL is going to be, it looks like, well, that's towards the morning. LCL, I'm not too concerned about that, but the biggest thing for me is, I mean, you have the veering, you have the parameters in place for, again, all modes of severe weather, but as we just saw here on this sounding, which is having trouble outputting, this Cape profile highlighted in pink is really skinny. So whenever you see a Cape profile like this, where it's like really skinny, there's not like a big mouth or big tongue, right, to where this line, this pink line, is all the way out here, well, that's telling us that there's not much convective available potential energy to work with. So the skew-T, this sounding, even just from Shreveport and even just looking at the GFS, is showing us that there is still uncertainty here with the instability, as we just established on our model runs. And by the way, this is also the European model too. The European run of this is also showing a very similar approach here, right? We don't really have much of a temperature inversion, and also our Cape profile is really damn skinny. So if we're looking at a skinny Cape profile like that, that's telling us it's it's sort of mixed bag right now. I mean, it's either going to be a low Cape profile day or a modest Cape profile day of greater than 1,000 joules per kilogram. So just to recap, as we put a bookmark on the severe weather discussion, it really is going to come down to Cape. That's it. As well as timing and the system evolution, which will be resolved over time. But the biggest thing is the Cape. And so we'll have to keep you posted over the next couple of days, and we'll revisit all of this during our future discussions here. If you have any questions, by the way, post those down in the comments below. I'll be happy to get to those as well and answer them. But let's finally end tonight with taking a look at the winter weather side. And I'm just going to show you, we'll revert back to the jet stream map, and just to give you an idea, I will conclude by showing you a graphic that you guys will find funny. Okay, I promise. You'll get a laugh. So as we go forward in time, by the time we get to Thursday, that's our winter threat. So let's kind of recap here. Cutoff low according to the GFS. Then you have a shortwave trough that develops downstream. That cuts right through the northeast. And then you get some backed westerly flow. Hey, if you're in the Great Lakes, I'm concerned about you. All right? I am concerned about you, because if I'm seeing westerly flow like this, that's enough fetch to produce some snowfall in places like Lake Ontario and all the way back for our folks in Grand Rapids and the UP. Just saying. That's where my confidence is very high right now for you guys, even this far out. So we want to keep, we'll keep you posted on the lake effect side of this. Of course, with lake effect snowfall amounts, we really don't know until closer to the event because of how small scale that system is for lake effect. You need higher resolution models to resolve that. GFS is not going to do a good job at trying to resolve lake effect snow, but it will hint at it, right? So this is the jet pattern that's really going to be responsible for potentially some snowfall here for the Northeast and New England. This is the funny part. All right, you ready? I am. Here we go. Here is the forecasted snowfall for what would be essentially the 23rd. So actually, no, I lied. This is the Thursday, Friday system. Then there's another system behind it. So this morning, if we were to go all the way back to this morning, look how much snow it was forecasting for the New England states. 23 inches of snow. There was even a point of like 40 that was showing up here once upon a time. Very unlikely, right? And we're already seeing that by the 18Z. Actually, you know what? Was that the 18Z? Oh, it is. Okay, cool. Never mind. So, right, so we're seeing less of that snowfall in this case. More of that kind of ensue on the secondary system, but that's also very far out. But here's really where we're at with our snowfall. So most of it sort of coming in central New York or coming from central New York, and then Vermont, New Hampshire, and some of the higher elevations. You do have some snowfall measurement around, say, 1 to 2 inches. So point is, I guess the joke or the punchline was really supposed to be, we had a model this morning showing 40 inches of snow for Massachusetts. Meanwhile, the GEFS, which is looking at the average, was showing snow to the north, and it still does today. So here's where we're at with snowfall. I'm not showing you a lot of products tonight on the snowfall side, not because I'm being lazy. It's because I feel that would be incredibly redundant to go over that right now because I know for a fact this is going to change. And so do you. If you see anybody posting this map, if you see anybody posting on any social media, YouTube, Twitter, Facebook, etc., this snowfall map, not necessarily this one, but one that shows like 30 inches of snow hitting Massachusetts, please, promise me you will take it with a grain of salt. Don't put your eggs in one basket with that map. Guys, as I've mentioned here now several times during this video, the system of concern is still off the coast of San Francisco. We can't get good observational data right now. That observational data that we're feeding into it is not going to be as good until we can launch a weather balloon into it and get even more data than a buoy, a plane, or a cargo ship could do. So, we will continue to update you guys on this first system that is likely to impact the Northeast and New England in some capacity. Questions on who's getting snowfall, how much, and even when still needs to be answered, right? It's just too far out. We'll continue to provide updates and videos over the next few days going into next week. This would impact holiday travel at the moment, and we'll keep you posted. But like I said, if you see any maps out there, that's not to crap on anybody that's sharing a map. It's just you need to look at that with the idea that it's still too early. So anyway, guys, thank you so much for tuning in to our Friday night edition of our winter weather discussion. Winter weather discussion. Thank you so much for tuning in for tonight's weather discussion. As you can tell, I've now hit a brick wall because I'm fumbling on my words. I appreciate you guys sticking it out here. If you have any questions about anything we talked about in tonight's video, put those down in the comments below. I'll be happy to answer those. And with that being said, have a great rest of your night, and we will see you on our next video. Take care.